Hey guys, it's Mrs. Van Dyke. I hope you guys are doing well, and I'm kind of excited to try this video teaching. The next unit that we're going to be doing is called Systems of Equations, which I love teaching, so I really wanted to do a video so I could actually teach it the way that I like to. And you should have seen there's a link for these notes. Now, if you don't have a printer, that's okay. Just have your own piece of paper so that you can follow along and you can stop the video at any time and write these notes. You'll also see a link for these notes, which is some practice problems. You'll also see a link for this spaceship UFO looking paper, which is some of the easier problems. And I'm also going to attach, this is all just for practice, this paper, what do you call when someone pays back a loan quickly? This one's more difficult. All these things are available for you. If you can't print them out, again, that's okay. You can still practice all these problems, and having graph paper might also help. To begin, so we are doing systems of equations. These are also called linear systems. And we're going to be solving these problems 3 different ways. The first one is going to be by graphing. The second way that we'll get to is elimination. And the third way is by substitution. We're starting with graphing because you just learned how to graph functions in the last chapter, so we're going to review that, and that's really all you have to know for how to do graphing. So first of all, a little definition of systems of equations or a linear system. Remember that linear means it's a line. These are all straight lines. Definition is 2 or more linear equations. And again, I do encourage you to write this because you're going to learn more by writing versus just watching. 2 or more linear equations with the same variables. Now, this says 2 or more linear equations. We're only going to be dealing with 2 equations, but you could have 3. If you have, like we're going to have 2 equations, that means you're going to have 2 variables. If you had 3 equations, that would be 3 variables. So those are possible to solve, a little more challenging, still fun. Here's an example. You could have an equation in slope-intercept form, y equals 2x plus 3, and another one not in slope-intercept form, 3x plus 5y equals 10. So 2 equations, they both have the same 2 variables, x and y, just a random example. A solution, of course, a solution means an answer. A solution to any systems of equations, it doesn't matter how you solve it, a solution is always an ordered pair. And this ordered pair is true for both equations, and I'll show you that when we solve these problems. This is really how you check it. That is true for both equations. All right, so basically all these steps we're going to go over here is how to graph something. So this should be review. You're always going to want to make sure to start your equations in slope-intercept form, which is y equals mx plus b. Hope you've got that memorized. Identify the slope, the m, and identify the y-intercept, which is b. And you're going to have these 2 equations, you're going to graph them on the same coordinate plane. So graph both lines on the same coordinate plane. Once they're graphed, all you have to do and see is where do they cross, where do they meet. Find the point of intersection, which is an ordered pair. So this ordered pair, just a point, is the solution. That's all we're finding. So graphing is good to see because it's visual, so you can actually see where these lines are crossing. And of course, we can always check our solution. We should be happy that we can. check the solution in both of the original equations. Remember that what this means by original is if one of your equations or both of them weren't originally in slope-intercept form, then you might have had to have rearranged it to get it into slope-intercept form. So put your solution into the original equation in case you made a mistake when you were rearranging. Now, there are some special cases. Some systems have no solutions, which happens when the graphs of the lines are parallel. So picture that. We'll see some examples. The lines are parallel and therefore they never intersect. And we've recently just had answers to problems where there were no solution. Some systems have infinite solutions. We've seen that also. And what does this look like? This occurs when both equations are graphed and they are basically the same exact equation. Maybe they don't look like it at first, but they're really different variations of the same equation. And in this case, all points will overlap, or as we're saying, intersect. Oops, sorry, hope you could see all those notes. Pause it if not. I'm going to flip my page over for some examples. We start off with some equations that are both in slope-intercept form. So these ones are easier because we don't have to rearrange, but we want to identify the slope and y-intercept for both of them. So remember, when you ask yourself y equals mx plus b, what number is in front of the x? That's always your slope. There is an invisible -1 here, and our y-intercept is a +1. And for this equation, the slope is +2. And our y-intercept is -b. Always includes the sign in front of it. So recall when you're dealing with slope, it's rise over run. And remember, our run always goes to the right. Rise can mean up or down. So if it's a negative slope, that means we're going down. And we often want to make our slope look like a fraction to help us graph. So we're going to call 2 over 1, and we're going to call -1 -1 over 1. So it tells us both the rise and the run. So you might want to have different colors to graph these. For the first equation, remember your starting point is the y-intercept where it crosses the y-axis. And my slope is -1, so down 1 over 1, down 1 over 1, down 1 over 1. And you can go the other direction, up 1 over 1 to the left, up 1 over 1 to the left. Remember to extend your line and draw arrows. And I'll do my other one in pink. My y-intercept is -5. And the slope is 2, so up 2 over 1, up 2 over 1. And I am very happy to see this. I'm seeing where the lines intersect. So it appears that they're intersecting at the ordered pair 2, -1. So this should be my solution, but I'm going to double check it and make sure. So recall it said substitute your solution into the original equation. So here's my first equation, y equals -x plus 1. This is your x, this is your y, so substitute in both. -1 is y. Be careful with all these negatives. -x would be -2 plus 1. Is this really true? -2 plus 1 is -1? Yes, check. And also try the second equation. So it might work for one, but you really have to try for both to know for sure. And it only takes a few seconds, so it's worth your time. Y is -1, x is 2. Is this true, that 4 minus 5 is -1? Yes, it is. So I am guaranteed, I'm assured that this is my solution, the point where the two lines intersect. Notice for the next one, number 2, that these are not in slope-intercept form, so we have a little bit of extra work to do. Remember, we're just trying to get the y by itself. So this is going to take one step to get y by itself. I'm going to get rid of this -x by adding x to both sides. Y equals x plus 5. And in this case, I want to get rid of this positive 2x. I'm going to subtract 2x from both sides. And I've got y equals -2x plus 8. Make sure when you're rearranging these to have the term with the x come first so that it's in slope-intercept form. And let's keep going. Identify our slope. For this first one, it's 1. For the y-intercept, it's 5. You know, it's really more fun, I'm realizing, when I can interact with you guys, but hang in there, I'm just going to keep going. The slope for the second one is -2, and the y-intercept is 8. So let's try graphing these. For the first one, my y-intercept is 5, and my slope is 1, so that means up 1 over 1, up 1 over 1, up 1 over 1, and you don't know where these lines are going to intersect, so extend your line, use a ruler if you want to so it's more precise. For the second one, my y-intercept is 8, and the slope is -2, so down 2 over 1, and I can see where they're intersecting already. And this is the point 1, 2, 3, 4, 5, 6. The ordered pair 1, 6 is my solution. By the way, your solution is the ordered pair, just to clarify that. This is the answer. The graph is not the answer. Any way that we'll be solving systems of equations, every single answer is an ordered pair, unless it happens to be no solution or infinite solutions. So let me check this out in the original equation and make sure it's really true. Then we're super happy again and can draw rainbows and stars, and yep, this is actually true. And 2x plus y equals 8, so 2 times 1 plus 6, is that really 8? Yes, 2 plus 6 is really 8. Yay, smiley face, rainbows. And I'll do one more with you. Might as well do lucky number 3. And I'll provide the answer for 4, so you can try that on your own and see if you get it. Number 3. Neither of these are in slope-intercept form, so my first step is to get that. I'm going to remember that we're always undoing addition or subtraction first, and then undoing multiplication or division. So I'm going to subtract 2x from both sides. 2y equals -2x plus 8. And then divide every single term by 2. Remember, that's a common mistake, not to divide every single term by the same number. And on this one, it's one step. Just get rid of that adding 8 by subtracting 8 on both sides. Y equals 2x minus 8. Let's identify the slope and y-intercept. My slope is -1, y-intercept 4. Slope is 2, y-intercept is -8. Let's graph them. My starting point is the y-intercept 4. My slope is -1, so down 1 over 1, down 1 over 1, down 1 over 1. And a little bit the other way, up 1 over 1 to the left, up 1 over 1 to the left. If I'm going too fast, just pause the video. And on this one, my y-intercept is -8 way down here, and my slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. Being neat is really important. And if you're doing this on your own graph paper or regular paper, just draw the lines and everything as neatly as you can. So now, also, especially if you're doing this on your own paper, then neatness is important, and not just saying, oh yeah, this looks like 4, 0, but you really, really want to check and make sure that you graphed it correctly by checking in the original equations. So 2x plus 2y equals 8. Substitute x is 4, y is 0. 8 plus 0 is 8. Check. And the second one, the original equation, just in case I made a mistake when I was rearranging. Y is 0. X is 4. Yep. Absolutely for sure, 4, 0 is my solution. I'm going to let you try this one on your own. The answer should be 4, -1. That will be the ordered pair. Now a little bit more, switching gears to this paper. I'm only going to do a few examples just to point out our special solutions. starting with number 1. On number 1, you'll notice that the slopes are the same, but the y-intercepts are different. That's something that you're going to want to pay attention to. So when this is going to happen, or you're going to see what happens every time the slopes are the same, but the y-intercepts are different, this is what happens. Let's plot them. The first one, y-intercept is 2. Our slope is 3 over 2, so up 3 over 2 to the right. I'm going to go the opposite direction, down 3 over 2 to the left. And the second one, my starting point is 4. And I'm still going up 3 over 2. I'm going to go off the graph, so I'm going to go the other direction, down 3 over 2, down 3 over 2 to the left. And you notice that these lines end up being parallel, which means they never intersect. There is no solution. And that is our answer. No solution because they never intersect. So anytime you have the same slope, you know that the lines are going to be moving the same way, up and over, but they have different starting points. They will never intersect. Let's try a different one. Look at number 2. These ones have different slopes. So slopes are different. Now, it really doesn't even matter what the y-intercepts are. If the slopes are different, you're going to get this same type of answer every time. So let's graph. First one, a y-intercept of 3. The slope is up 1 over 2, up 1 over 2. And the other direction, down 1 over 2 to the left. Our second point starts at 1, and this one has a negative slope, down 1 over 2. Now I'm going to go the other way, up 1 over 2, and I can see where they intersect. And we actually have a solution. So this solution is -2, 2. All you have to realize right now is that if there are different slopes, there is always one solution. And that's what type of answer you're going to get most of the time. Just things to be aware of and to recognize when you're going to get one solution. The answer is not one solution. The answer is the ordered pair. Turn the paper over for the last example, number 5. And I'm actually going to change number 5. So you notice these are the exact same equation. Normally, they're not going to give you the same equation twice. So let's just cross off one of these and call it instead 6x plus 3y equals 12. So let's say these are the 2 original equations. This one's not in slope-intercept form, so you know that you have to get it into slope-intercept form first. Let me give myself more room. So I'm going to subtract 6x from both sides. 3y equals negative 6x plus 12. I'm going to divide every single term by 3. And now what do I realize? This is how the problem would more normally occur. 2 different equations that you start with, and then as you get one of them into slope-intercept form, you realize they're the exact same equation. So, of course, if we graph this, one line is going to be basically lying right on top of the other one. It's the same line. Which means it's going to be infinite solutions. Every single point is touching every single point. And that is your answer. As you look through these practice problems, systems of equations target practice, notice that every single equation here is already in slope-intercept form, so these are easier because you don't have to rearrange them. What it's asking you to do is to graph each of these and answer which number UFO it is intersecting. So if we do this first one, our y-intercept 6, our slope is 1, or 1 over 1. So up 1 over 1, up 1 over 1. I'm going to go the other direction. It looks like it's going to intersect with UFO number 6, but let me graph the other one to make sure. This one starts at -4, and it's a slope of -1, so down 1 over 1. but I'll go the other way, up 1 over 1 to the left, up 1 over 1 to the left, and keep going. And yes, these do intersect at number 6. So this is how you would answer this. I'll provide the answers on the website, but this is a easier practice for you. And here's a more difficult practice for you, only because none of these equations are in slope-intercept form to begin. So that'll be your first step. You will have a lot of graphing on here. You might want to use different colors, like if you have 12 different colors. And you're going to also find out where do these intersect, and I will post the joke answer. So these are practice for you. We're not turning these in. I'm going to post quizzes, and that will be your proof to me that you understand how to solve systems of equations by graphing. Talk to you soon. Bye.